According to airline flights on a certain route are on time 80% of the time. Suppose 8 are randomly selected and the number of on-time flights is recorded. Does the probability experiment represent a binomial experiment? So we have 4 conditions we need to check. We want to know if there's a fixed number of trials. Okay, so we're good here, right? We have a fixed number of trials. So n is 8. We're going to check to make sure our trials are independent, so the flights being on time doesn't depend on another flight being on time. So we have independent trials. We want 2 outcomes, two mutually exclusive outcomes. So they're either on time or not. And then the probability of success is the same for each trial. So probability for each trial. Probability here is 80%. So our 4 conditions are met, so we have a binomial experiment. So we want to find and interpret the probability that exactly 6 flights are on time. And they're on time 80% of the time. So we have that n is 8, p is 0.80, and then we want to write our probability statement. So the probability that x equals 6, so that exactly there indicates equals. So again, we're going to go into StatCrunch. We're going to do stat calculators binomial. So we're going to do stat calculators and binomial. And then we're going to type in our n, which is 8, our p, which is 0.8, and then our statement. So the probability that x equals 6, and then hit compute. And our probability here is approximately 0.2936. And then we want to interpret here. So we're talking about out of 100 trials, I can take this and multiply it by 100. There's about 29 of them. So in 100 trials, we expect about 29 to result in exactly 6 being on time. So now we want to know at least 6 flights are on time. So again, our n is 8, p is 0.80, and our statement is the probability that x is greater than, so at least means greater than or equal to 6. We're just going to come into the standard calculator part of the binomial, change that to greater than or equal to, then hit compute. So this is approximately 0.7969. And again, we're looking out of 100 trials, so if we take that answer and multiply it by 100, we're looking at 39.69, which is about 80. So you would expect about 80 of them to result in at least 6 flights being on time. So the next one, we want fewer than 6 flights. So again, n is 8, p is 0.80, and we want fewer than 6. We're not including 6, so x is less than 6. So the probability that x is less than 6. So again, we're going to look at this in StatCrunch. So we're going to change this to less than and hit compute. So this is approximately 0.2031. Again, we're going to multiply by 100 to help us interpret. And we're looking at about 20 flights. So multiple choice. In 100 trials and experiments, sorry, not 20 flights, 20 of the trials. So we would expect about 20 of the trials and experiments to result in fewer than 6 flights being on time. So last part here, between 4 and 6, inclusive. So inclusive here means that these values are included. So we're talking about values of 4, 5, and 6. The probability that x is between 4 and 6. And again, n is 8, and p is 0.8. So we're going to switch to the between part. So you're just going to click up here on the button for between, and we're going to change our values to 4 and 6 and hit compute. So this is approximately 0.486 here. So that would be, again, we multiply by 100 so that we can interpret. We're going to have 100 trials experiment, 48.63. We round to the nearest whole number. We're looking at about 49 of those trials to result in between 4 and 6 flights, inclusive being on time. So there's another example of a binomial experiment.